All right, let's do example 3.3. So 3.3 says a web page designer creates an animation in which the dot on the computer screen has a position given as this function in centimeters. Find the magnitude and direction of the dot's average velocity between 0 seconds and 2 seconds, and find the magnitude and direction of its instantaneous velocity at 0 seconds, 1 second, and 2 seconds. So average velocity, that's going to be a lot like the one we just did before this, where we're going to have to look at the x component to find the x displacement, and then find the x component of the average velocity and do the same thing for the y. So remember, when we do our average velocity, v average, it's always going to be our displacement, so our final minus our initial. So I need essentially my x position at 2 seconds minus my x position at 0 seconds divided by 2 minus 0 for my time. So I need to plug that in up here. So a cool little thing happens here. So if I plug this in, I get 2 squared is 4, 4 times that is 10. So I have 10 plus 4 for my initial, which is 14, minus my initial, which is 4. So really that initial position kind of cancels out because all we care about is how far did you go. We don't care about your final position actually. So those two 4's kind of cancel for us, divided by 2, and so I end up with 5 for my, or 5 centimeters per second I should say, for my average velocity in the x direction. For the y direction, same kind of idea, average in the y. So we're going to do our y at 2 minus our y at 0. So we're going to have 10 minus 0 divided by 2 minus 0. So again, we also get 5 centimeters per second in that direction. It really would be nice had they asked us just for the components, but of course they ask us to find the magnitude and direction. Let me double check that. Yes, they ask us for magnitude and direction. So we just need to put those two together. And so, of course, always draw them. So I have 5 and I have 5, and that gives me 5 squared plus 5 squared, 7 point something. Let's take a look. 7.07. 7.07 centimeters per second at, and my angle is going to be 45 degrees because they're equal, 45 degrees, and given our direction here, we're going to say this is counterclockwise of the positive x-axis. All right. Now, average velocity, I really want to have the displacement. I need the displacement, so I need a position function to find my displacement in order to find my average velocity. For part B, they ask us for the instantaneous velocity. So to find the instantaneous velocity, we need a velocity equation evaluated at those time intervals. So we're just going to go ahead, take the derivative here. So our 4 goes away, we're left with 5t I hat plus just 5 j hat. And of course, this is all in centimeters per second with time in seconds. So now I can just plug in, well, what's your velocity at 0? It's just 5 j hat centimeters per second. Do they ask for magnitude and direction? They do. Oh, such a bummer. So I need to say that that is going to be 5 centimeters per second in the positive y-axis direction. All right, so then the velocity at 1 second looks like it's, hey, 5 and 5. We know that one already. That one's going to, so it's 5 I hat plus 5 j hat. We can put that all together. We get that 7.07 at 45 degrees. They're both positive, so that is going to be counterclockwise of the positive x-axis. And then our last one, the velocity at, was it 2 seconds? Was that the last one they wanted? Yep, the velocity evaluated at 2 seconds. So we got 10 I hat plus 5 j hat. So same kind of pattern, putting those together. So we're going to go 10 over, 5 up. Put in the Pythagorean theorem, and we should end up with 11.18 centimeters per second at 26.6 degrees. And this is also going to be counterclockwise of the positive x-axis. So again, wrapping this one up, average velocity, the average part of that, you're going to want to use your displacements you're going to need the final position minus the initial position to do that, whereas instantaneous, you need to go ahead, take that derivative, get that velocity function, and solve. There you go.